Hello, my name is Guillermo Fernandez Jungent, and today I will be doing 3 out of the 6 problems of the lab section 5 for the second partial project of math. So, to begin with, our topic is probability. Some background information about this topic is that probability is about what's the way or how or what's the amount of probability that something happens. So it's a way to measure the odds of something, as in some words. And I will be doing the first problem, which is already written here. So here it says that the P parenthesis B parenthesis this means probability of B. That means what's the probability of obtaining B. And here it's probability of obtaining A and B. So probability of B is 1 out of 20 and probability of A and B it's 3 out of 80. Those are the probabilities that will happen. And the question, with this information, it comes to the question, find the probability of A. So what do you need to do to find the probability of A? So first of all, you have all the information you need. So what you need to do is to find the probability of A, you need to divide the probability of A and B by the probability of B. In this way, you will get the answer you're looking for. Because you need to divide this, it's 3 out of 80, it's meaning that there's A and B. So if you want to disappear the B, you need to divide by it. So this means 3 out of 80 divided by 1 out of 20. So when it's done in the calculator, so here's the calculator, so you do 3 out of 80 divided by 1 out of 20, you get 3/4. So probability of A is equal to 3/4. Or in other words, in percentages, it is a 75% chance to happen probability of A. So in this second problem, letter B, you need to find, with this information you have, the probability of A it's 3 out of 8. And the probability of B is giving you that it is 23 out of 30. And here the question is the probability of A and B. So what you need to do to find the probability of both of them, to find the probability finding A and B together, you need to multiply probability of A times probability of B. Because if you multiply them, you will get all the probabilities possible, and that's what you're looking for. So probability of A, it's 3 out of 8. You need to grab that and multiply it by the probability of B, which is 23 out of 30. So while using the calculator right here, showing you need to do 3 out of 8 and multiply it by 23 out of 30. This will give you 23 out of 80. So this all equals to 23 out of 80. The probability of A and B is equal to 23 out of 80. But if you wanted to get it in percentage, in some type of percentage, you need to do 23 times 100 divided by 80 gives you 28.75% probability of both of them happening. So it is actually the same answer, only that one of them comes in percentages and the other one comes in a fraction, as a fraction. Thank you.
And number C, D, and E. So in this case, they're asking us for the probability of B, and so where we're gonna use certain formulas. In this case, we're gonna use a probability of B given that A already happened, which is P is this probability of A times probability of B divided by probability of A. So we know that the probability of B, given that A already happens, is 3/4 is equal to probability of A, which is 5/6 per probability of B that we don't have, divided by 5/6. So we're gonna end up having, so we cancel the same numbers that we have that are in the numerator and the denominator. So we're gonna end up having 3/4 as a probability of B. In this case, probability of A is 3/20, and the probability of B 7/10. And when they're asking us for the probability of B, given that A already happened. So in this case, we're gonna use this formula as the same formula as before. That is probability of A times probability of B divided by probability of A. So in this case, we have 13/20 times 10/10 divided by A, 13/20. So in this last exercises, they're asking us the probability of both events happening, such as A and B. So in this case, we're gonna use this formula, which is probability of A union B. So is the probability of A sum with the probability of B minus the probability of both events happening. So we know that probability of A is 7/10 plus the probability of B, which is 1/2, minus the probability of both event happening. So both event happening is 7/10 times 1/2, which gives us to 0.46. No, it gives 0.35. So minus 0.35 is gonna give us 0.85 or 17/20.
So this is the last problem that I will be doing. It is the last one of section 5. It is letter F. So first of all, you can see here that the probability of B is 9/20, while the probability of A and the other one is the probability of A given that B already happened. So that's why this long sticks in the middle, because it represents the probability of A. This means given that B already happened. So with this information, you can use this formula. You can use this formula that goes like this: probability of A equals to the probability of B multiplied by the probability of A given that B already happened, and you divide it again by probability of only B, because you want to obtain the probability of only A. This formula can be done if both the probabilities are independent, and in this case, in this problem, they are, so we will be using this formula. So the probability of B is 9/20. You multiply that by 7/20, which is the probability of A given that B has already happened, and you all divide it. You divide it all by once again 9/20, which is the probability of B. And you do this on the calculator. You do 9/20 multiply by 7/20, and then you divide it all by 9/20 again. That's the formula, because you only want A, the probability of A, so you divide it by B. That gives you 7/20. So the probability for only having A is 7/20. Another way you could do this is easily, you could have just seen that in this formula right here, there are two fractions that are the same, and that it's when it's multiplication, you can cancel them. So you could have canceled them, and you would have ended up with the same answer as right here. So it is the same. It's a way to see to check your answer, and it is correct. So the probability of only A is 7 out of 20. And if you want to make 7 out of 20 a percentage, it will give you 7 times 100 divided by 20 will give you 35%. It will be 35% probability that it's A. Thank you very much.
Hey, how's it going? My name is Gerardo and I will be explaining to you confidence intervals. In terms of statistics, a confidence interval refers to the probability that the value of a population parameter will be between two sets of numbers. This will be for a certain amount of times. The confidence intervals are used to measure degrees of certainty or uncertainty. They can take any number of probabilities, but the most common ones are 90%, 95%, and 99%. Let's see an example. The example reads, in a random sample of 48 students, it has been found that the average weekly consumption of alcohol was 2.4 liters. Assume a population standard deviation of 1.2 liters. And construct a 90% confidence interval for the weekly average consumption of college students. After reading the problem, we have to check for these 4 rules. First, we need to see if this is a normal or random sample. In this case, it is a random sample, but it is more than 30. So we know that n represents 43. After that, we know that the average consumption of alcohol was 2.4 liters, so that is our mean. And we also know the standard deviation, which is 1.2 liters. Step number 2 is to find the critical value of z alpha divided by 2. So I already wrote that there is a 90% confidence interval. And to get the critical value, we need to subtract 90% from 1, and then we get 0.1. This should also be divided by 2, so we can get 0.05. This is equal to alpha divided by 2. And if we check our table, we know for certain that the critical value, by checking our table, is equal to 1.695.
So from where Gerardo left off, we only need to find now the margin of error and the confidence level interval. And for margin of error, the only thing we have to do is multiply our z alpha times standard deviation divided by the sample number, which in our problem is 1.695 times 1.2 divided by the square root of 43. And the answer to that is 0.310. And now that we have this value, the only thing we have to do is subtract 0.3 from the mean, which is 2.4, and we get 2.1. Now we add 0.3 to 2.4 and we get 2.7, and this is our confidence level interval. 2.1 is more than 2.7.